Have you ever wondered how wireless charging works? The power is transmitted through air without connecting the phone directly to the power source. Today we will do a simple demonstration to show you how this wireless power transfer works. With me here is a light bulb, an AC power source, and two coils of wire. We first connect one coil of wire to the power source and the other coil to the light bulb. If we turn on the power source, we can transfer the power simply by putting one coil of wire on top of the other, like this. So, why can we do that? First of all, the power source is passing an alternating current through the coil of wire, creating a time-varying magnetic field around it, as seen by the moving compass. The magnetic field is then sensed by the second coil, generating a voltage that drives the current through the light bulb. This is called electromagnetic induction. The same principle of induction is also used in an AC transformer, which is used to change the voltage of a power source. Ideally, the voltage scales with the number of loops in the coil. So if we have a primary coil with n number of loops and the secondary coil with 2n loops, the output voltage will be doubled. Here we can see how the transformer works in real life. We have a primary coil with 400 loops and a secondary coil with 1600 loops. If we connect the primary coil to a voltage of about 6 volt, we will expect the output voltage to be about 24. Does that work? Let's see. When we put the coil next to each other, the secondary coil's voltage is still 0. Even if we put the coils on top of each other, the induced voltage is small. This is because the magnetic field generated in the primary coil goes everywhere, so very few of it goes to the secondary coil. This is known as leakage flux. To reduce leakage flux, we can put an iron block to guide the magnetic field like this. Notice that the voltage is significantly increased with the iron block. However, the induced voltage is still only about 10 volt, not 24. This is because the U-shaped iron block still has an opening, also known as air cap, on the top. By closing this air gap, the voltage of the secondary coil becomes about 24 as expected. What about the efficiency of the transformer? Since the two coils have resistance, there will be power losses and efficiency will be less than 100%. Here we have connected the secondary coil to a 250 ohm resistor and a switch with voltmeters and ammeters to monitor the voltages and currents in both coils. When the switch is open, there is voltage induced in the secondary coil but no current, while there's a current flowing through the primary coil because of the resistance of the primary coil. When we close the switch, a current is induced in the secondary coil, but the voltage dropped because of the current. Based on the measured voltages and currents, we can calculate the output power to be about 1 watt, whereas the input power is about 1.9 watt. So the efficiency is only about 53% for this circuit. The actual efficiency of a real transformer will depend on how it is designed and also the size of the load. I hope this video helps you to understand more about electromagnetic induction and transformer. Stay tuned for my other videos about energy. Bye bye.